This is numbers 9 and 10 on the diagnostic test. So for number 9, we have a simplifying problem that's going to combine the squaring technique that we did on the last question with subtraction. So we have to basically combine those rules. And we have to make sure that we're following those rules even if we know those rules. And what I'm referring to basically is PEMDAS, which we all know what it stands for, but sometimes we have trouble following it, specifically here. So the squaring operation is an exponent, so we're dealing with e, and the multiplying by -3 is an m. So PEMDAS is saying that the exponent has to go first, which means that I cannot multiply this by -3 and then square the answer. That's going to be a violation. So I have to make sure that I'm doing the exponent first. And as I showed you in the last video, I would always write it out so it doesn't look like x plus 6 squared, because people get that wrong all the time. You're going to write it out as x plus 6, x plus 6. And since those are 2 terms times 2 terms, and you have to multiply them by each, that means there should be 4 terms in your answer, not 2. That's why the answer can't be x squared plus 36. That's an absolute no-no. So I have to multiply it all out, and you can do it however you want to. I'm just going to do it here. Now, if you saw in our last video, we learned the squaring technique. I'm actually going to demonstrate that here. So a lot of this I'm going to be doing in my head. So remember that it's square the first, double the product of the square and the second, so if, the first and the second. So if I multiply 6 and x, I get 6x, obviously, but it's 6x plus 6x, which is 12x. So it's going to be double 6, which is 12, and then second one squared, which is 36. So x squared plus 12x plus 36 is the answer to the first. Now, I'm going to multiply 3 by the answer to x minus 9 squared. And again, x minus 9 squared is x minus 9 times x minus 9, and let's use the pattern again. So it's first one squared, first term is x, so x squared, double the product of first and second, so product of first and second is 9x, double that is 18x, and then last one squared, 9 squared is 81, so that's x squared minus 18x plus 81. So that's the advantage of doing the pattern. Now I'm going to do the multiplying. So after the exponent evaluation comes the multiplying, and now I will distribute that -3. That's -3x squared, plus 54x minus 243, and then finally I will add and subtract, which is basically combining like terms. So x take away 3x, remember to go in descending order of powers, standard form only, x squared, -2x squared, and then, oh that's a plus, I'm sorry, 54 plus 12 is 66x, and then 36 minus 243 is -207. And since these have different exponents, I can't combine them, and that's number 9. Okay, so now we're going to move on to the section containing radicals. So if you're not familiar with the radical rules, here is a good time to go over them. So A and B are sort of different sides of the same coin. A is asking us to simplify the square root of 250, and B is asking us to multiply them together. So there's a rule that states that the square root of a product is equal to the square root of the first times the square root of the second. Notice there's no plus sign in there. I'm getting to there later. So if there's a plus sign in the problem, it's a whole different ballgame. When two things are separated by multiplication, you can break them apart. So that's what I do to do square root of 250. Now, in this one, your first square root has got to be the highest perfect square that goes into 250. Okay, and your perfect squares are 1, even though it doesn't really mean anything, 4, 9, 16, 25, and so forth. So the highest perfect square factor that goes into 250 is 25. So I'm going to split the square root of 250 into the square root of 25 times the square root of 10. Okay, and so the reason I do the perfect square is so that I can get a whole number out of it. So square root of 25 is 5. Notice not radical 5, just 5. And square root of 10 is a decimal, so I leave it the square root of 10. Okay, this is what you call simplest radical form. And you'll see that a lot in this course. Okay, now multiplication, like I said, the opposite side of the same coin. So this time we're going this way, and I multiply these together. So the square root of 20 times the square root of 8 is the square root of 160. Now I'm going to re-simplify this again using the rules that I did in part A. What's the highest perfect square factor that goes into 160? That's right, it's 16. So this is 16 times 10. Break them apart. Square root of 16 times square root of 10. Square root of 16 is 4. So this is 4 radical 10, and that's the simplest radical form of that. Okay, I'm running out of room, so I'm going to do C down here. Square root of A squared, B squared. Now, compare C with D. Remember what I said about that plus sign? If a plus sign exists in there, or if two things are separated by plus or minus, this rule is off and it cannot be simplified. Does C have a plus sign in it? No, so I'm perfectly fine to break it apart. That would be equal to 8 square root of A squared times the square root of B squared. And then I can take the square root of each one. So, square root of A squared is A times the square root of B squared is B, and that leaves me with AB. Okay, so let's do D. Now D has a sum. Now, most people are very much inclined to do this. But that would be wrong. Notice that's not the rule. The rule states that only a product can be broken up. So if those two things are not separated by multiplication, this is not going to follow the rule, and so this is not the simplified version. In fact, try something like this. Square root of 25, right, which we know to be 5, can also be expressed as square root of 9 plus a square root of 9 plus 16. That's 25, right? Now try to break it up. Okay, and do each part individually. The square root of 9 is 3, and the square root of 16 is 4, but this is supposed to be 5, not 7. So, square root of 25 is 7? Absolutely not. So that's why this doesn't work. Okay, but you try something like the square root of 36, which is supposed to be 6, right? Try to do it this way. Square root of 9 times 4, that's 36. Square root of 9 times the square root of 4 is 3 times 2, which is 6, and that works. So it has to be a product and never a sum. Okay, and that concludes number 10.